Hi everybody, this is Dr. Dan Puperi, and I'm back with the Python class. I've posted problem 3, which is reading and processing your spectrophotometer data using Python. Before you got into that, I wanted to give you some hints about how I would approach this problem. But the cool thing about solving problems in programming, there's a lot of different approaches, so you can do whatever you want. You can do it like I do, you can do it a different way, that's totally fine. But first of all, we know that our spectrophotometer outputs this data. And so I'm just going to open the file, my example file data, and here's basically the data it outputs. Now the problem with this is there's a lot of stuff that we don't really care about, and there's only a little stuff, which is actually the data in here, that we do care about. And one of the problems is this data is in a format that doesn't really tell us what it means. So there are a number of ways to define what the data means, but I'm going to go ahead and we're just going to add to this file, which will include the definition of what this data means. So down at the end of the file, we know that on line B here, this is my standard curve, if you guys remember from the experiment. And on line C, this is actual my experimental data. Okay, and so I want to somehow tell Python that that's what these things are. And so I'm going to make a line that's called standard curve definition. Okay, and so that's going to be a new section of this file that will define the standard curve. And then I'll have another one that I'll just call data definition. What I'm going to do is just go ahead and say B2, the concentration is 0.1 millimolar. In cell B3, the concentration is half that, 0.05. So I'm going to basically define the standard curve based on what location it's in on the plate reader. Now your guys' standard curves might be different than that. That's okay. This is just what this file happens to be when I did it. And so we had the 0 concentration. And so that's what my standard curve was from my lab notebook. And that's what all this data means up in the B column. Okay, and there's a couple of blank numbers because that's just how you had to read it and we don't care about, so I'm not going to define those at all. I'm going to do the same thing with this data definition, where we know that these readings are based on time. So in C2, that's at 1 minute. C3 was at 2 minutes. C4, 3, okay, and I think that's what I have here. So I actually have all the data from 1 to 90 minutes. You guys should have something very similar for your plate reader. But this lets the user tell somebody somehow that that's what all this data actually means. So I'm going to go ahead and save this file. And then when we process it in Python, we can get the meaning of what it actually is.